Before lab, we have to make sure that all of us are wearing proper attire. For example, shirts with sleeves rolled up and long pants, as well as goggles and gloves. Once we've gotten that down, we're able to start the experiment. After collecting the samples from the column, a small amount of each dye was put into different cuvettes and then diluted with deionized water.
Wait here, no, everybody just grab their own.
Once all the dyes had been diluted, the samples were then taken to the other lab to collect the UV visible spectrums. When taking the spectra readings, it's important to wipe two sides of the cuvette where the light will enter and leave the sample. This ensures an accurate reading. It is important to note that a scan at all wavelengths is necessary, and there are two reasons for this. One is that it's needed to help determine the absorbance spectrum of the samples. The other is that scans at specific wavelengths only measure the absorbance at that wavelength. So essentially, across all wavelengths, it gives you a spectrum, while specific wavelengths gives you the absorbance at that particular wavelength. When looking at the data collected, you may notice that there are peaks higher than the others. This peak is referred to as the lambda max, which is the wavelength that the sample has the strongest absorbance. Displayed here is the Beer-Lambert law, and basically this law states that the relationship between concentration and absorbance of a solution is linear.